Hi everyone, in this video we will learn about approximation, estimation, significant figures and rounding of whole numbers and decimals. Approximation is the process of rounding of a given number to give an approximate value. Approximation can be used to quickly decide how many items you can buy with $5, for example. Approximation includes estimation, rounding to powers of 10, decimal places, and significant figures. While the estimation is the process of guessing the value of an unknown quantity in real life. So for example, if I write over here 125.47, so you can put it here in the place value chart. So 5 ones, 2 tens, and 100. This is 4 tenths, 7 hundredths. Rounding of whole numbers and decimals. What is rounding? Rounding means making a number simpler but keeping its value close to what it was. The result is less accurate but easier to use. How to round numbers? First, mark the position of the rounds of digit. Second, note the digit to the immediate right of the round off digit. If it is less than 5, replace it and all the digits to its right with zeros. Leave the round off digit unchanged. But if it is 5 or larger, replace it and all the digits to its right with zeros. Increase the round off digit by 1. So for example, round off 74 to the nearest 10. 4 is ones, while 7 is tens. So the nearest 10. What's the next number after 7? This is 4. 4 is less than 5. So the answer is 70. Next, round 86 to the nearest 10. This is ones, this is 10. Where's the next digit after 8? Is 6. So we must round up. So the answer is 90. Another example. Let's say 53. Round off 53 to the nearest 10. 3 is in the ones place, 5 is in the tens place. We want to keep the 5 so that you must look at the next digit. This is 3, which is less than 5. So no change is needed to 5. So the answer is 50. But if the question is 57, round off 57 to the nearest 10. 5 is in the tens place. So that's the next digit after 5 is 7. 7 is more than 5. So round up. So that you must increase 5 by 1 to get 6. So the answer is 60. Another example. This is 5,267,452. Round off this number to the nearest 10. You may put it here to the place value chart. 2, 5, 4, 7, 6, 2, 5. To the nearest 10. 5 is in the tens place. After 5 is 2. So round down. So you just copy the rest. 5, 2, 6, 7, 4, 5, 0. Remember, 0, 1, 2, 3, 4 rounding down, while 5, 6, 7, 8, 9 rounding up. Next, to the nearest hundredth. This is 4 in the hundredth place. The next digit after 4 is 5. So round up. So 4 plus 1 is 5. 0, 0, and the rest you just copy. Next, to the nearest thousands. Thousands is the digit 7. After 7 is 4. So round down. This one becomes zeros. This is 7. Remain unchanged. And you just copy 5, 2, 6. Next, to the nearest 10,000. 6. The next digit after 6 is 7. So round up. 6 plus 1 is 7. Over here, you write it with the zeros. 5 and 2 here. And then to the nearest 100,000, the digit 2, this one. After the digit 2 is 6. So round up. 2 plus 1 is 3. So 5,300,000. And then this one to the nearest million. This is 5. So the next digit after 5 is 2. So it means round down. So the answer is 5 million. In 2015, Singapore welcomed 17,400,000 overseas visitors. This value has been rounded off to the nearest 100,000. What's the largest and smallest possible number of overseas visitors? So the largest is 17,449,999. And then the smallest is 17,350,000. So let's check. If you round it off to the nearest 100,000, the next digit after 4 is 4. So we must round down. This is correct. And then let's check the second. If we round it off to the nearest 100,000, 3 is in the 100,000th place. The next digit after 3 is 5. So round up. So 3 plus 1 is 4. And this is also correct. Next, this one, round off each of the following numbers to the nearest 10. In 275, the digit 7 is in the 10th place. And then, we must check the next digit on its right. If it is 5 or more, we must round up by adding 1 to the digit in the 10th place. So 7 plus 1 is 8. And then, put the 0 in the 1's place as a placeholder. So the answer is 280. How about in 273.1? 7 is in the 10th place. The next digit on its right is 3. 3 is less than 5. So we round down. And the digit in the 10th place remains the same. And over here, don't forget, omit all the digits after the decimal point. So the answer is 270. And then this one, 96.482. 9 tenths, 6 ones, 4 tenths, 8 hundredths, and 2 1,000. Now, correct to 1 decimal place. One decimal place is the digit 4. And after that, the next digit on its right is 8. So round up by adding 1 to the digit in the 10th place. So 4 plus 1 is 5. And don't forget, do not add 0 after the first decimal place. So the answer is 96.5. How about to the nearest whole number? First, identify the digit in the ones place. The next digit after 6 is 4. 4 is less than 5, so round down. So the answer is 96. Remember, do not add 0 after the ones place. Why? Because the question is asking you to round off the number to the nearest whole number. And this one, correct 78.4695 to one decimal place. After 4 is 6, so round up. So the answer is 78.5. Do we need to put 0, 0 here? No need. Why? Because only one decimal place. Next, to the nearest whole number. So you must check the digit in the ones place. This is 8. After 8 is 4. So round down. So the answer is 78. Be careful over here to the nearest whole number. So you don't need to put the decimal. How about to the nearest 100? 7, 8, 4, 6, 9, 5. So this is 6. After the digit 6 is 9. 9 means round up. So 6 plus 1 is 7. So the answer is 78.47. How about this one? To the nearest 0.001. So means this one to the nearest 1000. The digit 9. After the digit 9 is 5. So round up. 9 plus 1 is 10. Six plus 1 is 7. So the answer is 78.470. Next, let's move on to the significant figures. Significant figures are used to reflect the degree of accuracy. There are 5 rules. Rule 1. All non-zero digits are significant. For example, 1.234. It has 4 significant figures. 1, 2, 3, 4. How about 56? It has 2 significant figures. Remember, all non-zero digits are significant. Next, rule 2. All zeros between non-zero digits are significant. For example, 302.008. It has 6 significant figures. Rule 3. In a decimal, all zeros before a non-zero digit are not significant. For example, 0.012. It has 2 significant figures. Remember, this is a decimal. All zeros before a non-zero digit are not significant. So, it only has 2 significant figures. Next, rule 4. In a decimal, all zeros after a non-zero digit are significant. For example, 41.0320. It has 6 significant figures. And rule 5, the zeros at the end of a whole number may or may not be significant, depending on how the number is rounded off. Let's practice the first rule. All non-zero digits are significant. State the number of significant figures in each of the following. For example, 7,258 has 4 significant figures. 192, 3 significant figures. 83.761, 5 significant figures. 3, 1 significant figure. 4.5, 2 significant figures. 1.234 grams, 4 significant figures. 1.2 grams has 2 significant figures. The second rule, all zeros between non-zero digits are significant. For example, over here, 302.008. It has 6 significant figures. 5,062, 4 significant figures. 1.09, 3 significant figures. 3.0024, 5 significant figures. 70.8001, 6 significant figures. 1,002 kilograms, 4 significant figures. 3.07 milliliters has 3 significant figures. Next, the third rule in a decimal. All zeros before a non-zero digit are not significant. For example, 0.021. 2 significant figures. 0.603. 3 significant figures. 0.00174. 3 significant figures. 0.10908. 5 significant figures. 0.001 kilogram. It has only 1 significant figure. 0.012 grams has 2 significant figures. Rule 4. In a decimal, all zeros after a non-zero digit are significant. For example, 0.10. There are 2 significant figures. 0.0500. There are 3 significant figures. 41.0320. There are 6 significant figures. 6.090. 4 significant figures. 0.023. There are 2 significant figures. 0.200. There are 3 significant figures. The fifth rule, the zeros at the end of a whole number may or may not be significant, depending on how the number is rounded off. So when a number ends in zeros that are not to the right of a decimal place, the zeros are not necessarily significant. For example, 190 miles. Maybe 2 or 3 significant figures. 50,600 calories. Maybe 3, 4, or 5 significant figures. The potential ambiguity in the last rule can be avoided by the use of standard exponential or scientific notation. For example, depending on whether 3, 4, or 5 significant figure is correct, we could write 50,600 calories as 5.06 times 10 to the power of 4 calories. This is 3 significant figures. 5.060 times 10 to the power of 4 calories. This is 4 significant figures. Or 5.0600 times 10 to the power of 4 calories. This is 5 significant figures. Next, 3,800 meters. Correct to the nearest 10 meters. So the answer is 3 significant figures. 25,000 km. Correct to the nearest km. So this is 5 significant figures. 100,000 gram. Correct to the nearest 10,000 gram. So this is 2 significant figures. Why? Look over here. If 100,000 divided by 10,000, so the answer is 10,000 grams. So this is 2 significant figures. Rounding off to given number of significant figures. To round to so many significant digits, count digits from left to right, and then round off from there. So for example, 1.239 rounded to 3 significant figures. So first, this number rounded to 3 significant digits is 1.24. Why 4? Look. After 3 is 9. So round up. 3 plus 1 is 4. 134.9 rounded to 1 significant figure. As the next digit is 3, which is less than 5, so round down. So the answer is 100. 0.0165 rounded to 2 significant figures. When there are leading zeros, such as 0.006, do not count them because they are only there to show how small the number is. So, 0.0165 rounded to 2 significant figures is 0.017. Why 7? Because after 6 is 5, so round up. 6 plus 1 is 7. Round off each of the following to the number of significant figures given in brackets. 8,982 to two significant figures. So first, identify the significant figures starting from the left. 1, 2, because two significant figures. After 9 is 8, so round up. 9 plus 1 is 10. So the answer is 9,000. Next, 0.0060195 to four significant figures. First, you must identify the significant figures starting from the left. Four significant figures. 1, 2, 3, 4. So start from here. This is wrong. Why? Remember the third rule. In a decimal, all zeros before a non-zero digit are not significant. So you may start from the left. 1, 2, 3, 4. Then check the next digit on its right. 5. So round up. 9 plus 1 is 10. The question is to four significant figures. If you write over here with 0, so 6, 0, 2, 0, 0, this is incorrect. Why? Because only four significant figures. So the answer is 0.00620. This is four significant figures. Next, 0.9999 to three significant figures. Remember, identify the significant figures starting from the left. This 0 is not significant. So 1, 2, 3. Then check the next digit on its right. This is 9. So round up. So 9 plus 1 is 0. So the answer is 1.00. Round off each of the following to the number of significant figures given in brackets. 3,748 to three significant figures. So the answer is 3,750 to three significant figures. Why? Look over here. Start from left, right? 1, 2, 3. So after 4 is 8. So round up. 4 plus 1 is 5. So the answer is 3,750. Next, 0.00470989 to four significant figures. So the answer is, you don't need to count the zeros here. So 1, 2, 3, 4. So round up. So the answer is 9 plus 1 is 10. The answer is 0.004,710. Next, 4,971 to two significant figures. So this is 1, 2. After 9 is 7. So round up. 9 plus 1 is 10. So the answer is 5,000. Next, 0.09999 to two significant figures. This is 0.10. How about three significant figures? 0, Next, 47,316 to 3 significant figures. 1, 2, 3. After 3 is 1, so round down. So the answer is 47,300. Next, 303,971 to 3 significant figures. 1, 2, 3. After 3 is 9, so round up. 3 plus 1 is 4. So the answer is 304,000. 20.453 to 3 significant figures. 1, 2, 3. After 4 is 5, so round up. 4 plus 1 is 5. So the answer is 20.5. 3 significant figures. Next, 0.004368 to 3 significant figures. 1, 2, 3. After 6 is 8, so round up. 6 plus 1 is 7. So the answer is 0.00437. Exact number. Some numbers are exact because they are known with complete certainty. It is obtained when you count objects or use a defined relationship. Examples of exact numbers are counted numbers of objects or certain unit conversions. For example, there are exactly 3 feet in 1 yard. There are exactly 12 eggs in a dozen. A class may contain exactly 25 students. Most exact numbers are integers, but it is possible for a value to have a decimal point. An exact number cannot be simplified or reduced. Rounding error. There is no need to round off exact values, but if an exact value has many digits, we can still round it off to 4 or 5 significant figures if it is in an intermediate step, or 3 significant figures if it is the final answer. So, in other words, if we want the final answer to be accurate to 3 significant figures, the non-exact values in the intermediate steps should be given to at least 4 significant figures. This kind of errors, which are due to rounding errors in the intermediate steps, are called follow-through errors. Follow-through errors can occur if non-exact values in intermediate working are not rounded off to a sufficient degree of accuracy. Rounding errors give non-exact answers to 3 significant figures if a question doesn't specify the degree of accuracy. Significant figures in intermediate working. The area of the square is 131 square cm. Find A, the length, and B, the perimeter. Remember, to get the area of the square is side times side, or length times length. Then how to get the side or length? We should find the square root of its area. Then how to get the perimeter? 4 times side. So here, to get its length is the square root of 131 is equal to 11.4455231423 cm. If we round it off to 3 significant figures, so the answer is 11.4 cm. Then how to get its perimeter? 4 times side. So 4 times 11.4. The answer is equal to 45.6 cm. If you add 11.4 times 4, a rounding error will occur.
To be more accurate, we should use the calculator value. So 4 times the square root of 131. The answer is 45.7820925692 pm.
Estimation of computations. Joy used a calculator to evaluate 31.5 plus 9.87 minus 2.1 and obtained the answer 392.7. Without doing the actual calculation, use estimation to check whether her answer is reasonable. So we are using the estimation, so 32 plus 10 minus 2 is equal to 40. Then, use the calculator to evaluate 31.5 plus 9.87 minus 2.1. The actual answer is 39.27. Now, is your estimated value close to the actual value? 40 is close to the actual value of 39.27. We use the approximation sign when it is not important to specify the degree of accuracy. For example, 31.5. We round it up, becomes 32. Overestimate or underestimate the value of a quantity. Without using a calculator, which option gives the better value for money? Look here, there are two options. Option A, 200 grams coffee powder for $5.80, and in option B, 200 grams plus 50 grams coffee powder cost $7.45. Although option A seems cheaper, but option A contains less coffee powder than option B. To find out which option gives the better value for money, compare the cost of coffee powder for an equal amount of coffee powder for both options. So there are two methods. So for example, this one is the first method. In option A, 200 grams cost about $6. So 100 grams cost about $3. 50 grams cost about $1.50. So 250 grams is 200 grams plus 50 grams. So this is about $6 plus $1.50 is equal to $7.50. So does it mean that option B gives the better value for money? In this case, we have overestimated the cost of 250 grams of coffee powder in option A. Now, let's look at the method 2. In option A, 200 grams cost $5.80. So this is about $6. So 100 grams costs about $3. And 50 grams costs about $1.50. So 250 grams. So 200 grams plus 50 grams. So this is $5.80 plus $1.50. So it is about $7.30. In option B, 250 grams cost $7.45. So option A gives the better value for money, since $7.30 is cheaper than $7.45. Estimation of area. Estimate the ratio of the area of the shaded region to that of the unshaded region in the figure below. To estimate the area, we divide the shaded region using dotted line into areas that are approximately equal to the area of the unshaded region. Since the unshaded area is on the right side of the figure, so start dividing the shaded region from the right side to obtain a more accurate estimate. So, the ratio of the area of the shaded region to that of the unshaded region is 3:1. That's all from me. Thank you for watching. Don't forget to like and subscribe.